Nobody ever says, oh, maybe today mathematics isn't working. It's just unheard of. You know, as a kid, I mean, you know, I had a hard time relating with other kids. I was obsessed by patterns. I just fell in love with mathematics. It was so much easier than dealing with people. From the age of about 10 or 11, I knew that I wanted to be a mathematician. Pi originally was the ratio of the diameter to the circumference of a circle. And that's still, you know, its definition. But it appears so much in other places in mathematics. And every formula that is used to describe the universe, almost every formula has pi in it somewhere. Without pi, you couldn't understand electrodynamics. You know, we take it so much for granted. In the middle of the night, you flick on a switch and suddenly you can read. 200 years ago, that was like, what? Well, you might have to burn a candle or something, but yeah, so we use it every day. So if you look at pi, if you look at the digits of pi, they look like random numbers. Do they behave like random numbers? Nobody knows the answer. For example, if I look at every digit, suppose I look at the digit 3. As I expand pi more and more, does the digit 3 appear about 1/10 of the digits? If it was a random number, the answer would be yes. Nobody knows. It might be that as you do the decimal expansion of pi, at some point, only the digits 0 and 1 appear. The only thing you know about it is it never stops and it never repeats. But you know, you could take 0, 1, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, you know, I mean, just, you know, whatever, some non-repeating pattern of zeros and ones, that might be what happens. Nobody has nobody thinks that's true. I mean, everybody thinks that every digit appears with the correct proportion of times, but nobody can prove it. And if you solve that problem, I mean, you'd be looking at a job. I mean, yeah, you'd be world famous. I mean, I think it'll be on the front page of the New York Times.